Alright, gang, today we're going to be doing the Mixing It Up lab. So, we should have 3 pages glued into our lab journal. Mixing It Up, part 1 is first, and that's questions 1 through 5. Then is questions 6 through 10. And the third page that's glued in is part 2, questions 1 through 9. Now we're going to go ahead and get all 3 of these pages glued in, but we're only working on this one today. So if you need to pause the video to get those glued in, go ahead. And I'm going to continue, and we'll start right here at the top. So the first question is, let's get a little better view here. All right, in a solution, the solvent is blank, and the solute is blank. Well, if you remember from our vocabulary words, the solvent is the part of a solution that takes the that dissolves or absorbs the material, and the solute is the substance that is dissolved into a liquid or solution. So one way I like to remember it, and we can add these notes at the top. So first off, let's draw a coffee cup. All right, with some coffee in it. And then what do our parents usually put into coffee to make it taste better? Right, a little bit of sugar. So let's add some sugar grains here. And then we'll draw a little spoon like we are like we're dumping some sugar into coffee. All right, now the solvent is the liquid that absorbs or dissolves the material. The solute is the substance that is dissolved, or the substance that is absorbed by the liquid. So we have coffee and sugar. Which one is the solute? Which one is absorbed by the liquid? The coffee or the sugar? The sugar is absorbed by the coffee, right? If we dump the sugar in, the sugar will disappear, the coffee will still be there. So the sugar is absorbed by the coffee, the sugar dissolves. So the sugar is our solute. And if the sugar is the solute, what's dissolved, then the solvent is what the sugar is dissolved in. So what is the sugar dissolved into? Well, we're taking our sugar and sprinkling it into coffee. So the sugar is dissolving into coffee. Coffee is absorbing the sugar. So coffee is our solvent. So let's add that. Solvent is coffee. These can get kind of tricky to remember. One way I try to remember it is that sugar and solute both have a U. So if we can remember that sugar with a U is the solute with a U, then we can remember that sugar is going to be a solute because sugar is what dissolves. And if we can keep that example in our mind, it can help us understand what other solutes might be. For instance, salt. If we put salt in water and stir it around, what will happen to the salt? It will dissolve into the water. So salt would also be the solute because that's what's dissolving. So if we can remember that solute has a U and sugar has a U, and we can remember that sugar is a solute. And so then if we're stuck with a substance and we're not sure, we can think, well, does it act like the sugar or does it act like the coffee? Does it act like the sugar and dissolve into the liquid, or does it act like the coffee and absorb the substance? So we can use this trick, matching up those U's, to help us determine some other future questions that we have. Another thing I want to add to the top here that is very quick and easy, the last thing we'll add to it, then we'll get started, is a small equation that is very simple, but very, very important. So this equation is solute plus solvent equals solution. And this is important because we're going to be dealing a lot with solutions. We're going to be talking a lot about solutes, solvents, and solutions. And it's important to remember that anytime we mix a solute into a solvent, that's going to give us a solution. So in this example, we're mixing our solute, the sugar, into our solvent, the coffee. And so our sweetened coffee becomes the solution. So let's get our question going. In a solution, the solvent is the liquid, I'm sorry, the liquid that absorbs a material. And we can say that the solute is the material that is absorbed by a liquid. Okay. Now what we're going to do today is we're going to watch how sugar is dissolved into water. Now if you remember from our previous unit, Properties of Matter, if we're talking about how well something dissolves into something else, that is called solubility. So we will be observing a sugar cube's solubility in water. And so we'll do this two different ways today. So two different ways we'll do this is we are going to just drop, we're going to follow instructions here. We're going to drop one sugar cube into 100 milliliters of water and just observe it for 2 minutes. And we will just write down what happens, what we see, what we think. Then we will discuss what we saw, and then we will take another sugar cube, put it into another 100 milliliters of water, and do the same thing. Watch it dissolve. But this time, we're going to change something up. This time, we will stir the water as the sugar cube is dissolving. And we will make our observations. And then we will come back and compare how the two different sugar cubes dissolved depending on whether we stirred them or whether we just left them. So, first off, let me prepare this. So we'll come here. I have my water cup. I'm going to pour in 100 milliliters. All right, that's about 60 milliliters. That is right at 100. All right, so we have our water. We'll set it here. Get our camera focused. Okay. And now I'm going to place this sugar cube in the water and we will watch it for exactly 2 minutes. So as we are, let me show you this really quick before we start. Right here on number 1, it says, record your observations below during the 2 minutes of a whole sugar cube in water. So while we are watching this sugar cube dissolve, we can also make some observations and take some notes about what we see. So I will first, we will just watch. You guys feel free to take notes on your observation as what's happening, and then we'll discuss it after. All right, so 2 minutes starting now. All right, so what do we notice yet? Well, if you're thinking nothing, you're exactly right. Nothing is happening yet. So we're about 20 seconds in. Still not a lot going on. We just keep observing. All right, we're about, zoom in a little bit here. Okay, now we can see something happening. If you look closely, you can see some particles breaking off the top and floating to the surface. Okay, that's an observation. All right, we're right at 1 minute. We can see more particles breaking off. Oh, they're starting to go fast now. See, we got particles shooting up, hitting the surface and drifting back down. If we watch this edge right here, we can see some changes happening. If we watch that very closely, it looks like little pieces are breaking off and tumbling down. All right, you can see it a lot on this other side. So is that a nice even edge anymore? It's not. Is that an even edge on top? It's not. You can see these divots. Oh, there goes a big piece. So we're seeing these divots get created. All right. And a few more seconds, we can see things breaking apart, right? We can see the sugar cube dissolving. Okay, and that is 2 minutes. So let's take this apart. And let's make our observations. So, record your observations below during the 2 minutes of a whole sugar cube in water. So what did we see? Well, at first nothing happened. And in science, that is an observation. If you're supposed to watch what happens and nothing happens, that's an observation. So, at first, no change. All right, then what did we see happen? What was the first thing we saw happening to the sugar cube? Did the sides start falling off, or did pieces start floating off the top? All right, well, what I saw, and you can back it up, feel free to back it up if you need to, but I believe that pieces started breaking off the top first, so we can write particles broke away from top of cube. And then after a while, we started seeing what happened to the edges, right? Those pieces started falling off. So we started getting big chunks falling off. So we can say the cube, can we say it changed shape? Do we think the cube at the end of that 2 minutes was the exact same shape as the cube at the beginning? No, not at all. It wasn't. Remember, those pieces were breaking down. Those pieces were falling apart. So the cube changed shape. Why did it change shape? From particles breaking away. All right, now number 2. What properties of the water changed as the sugar cube dissolved in it? What properties of the water stayed the same? So let's think about, thinking back on the water, what changed about the water? What did we observe that changed? Well, we saw the little particles floating through the water. We could see little pieces of sugar floating off of the cube. So we can say sugar particles were dissolved into water. All right. We saw that we could kind of see the sugar particles floating in the water. But do you think it made, when the sugar particles were floating in the water, did the water get hazy, or did it get cloudy, or did it stay very clear? I'll let you write whatever you think. So we'll say water clarity, and then you can say on this, I'm writing a line, but you write water clarity, talking about how clear the water is. If you think the water clarity stayed the same, if the water stayed very clear, then you can write water clarity stayed the same. Or if you thought it got cloudy, and if you thought the water became cloudy, then you can say water clarity became cloudy or foggy or milky. So anything you want to describe that. Now, what properties of the water stayed the same? Well, our amount stayed the same. Depending on if you thought the clarity stayed the same or not, you can add that on there. All right, let's move down to number 3. What properties of the sugar cube changed as it dissolved in the water? Well, that's pretty easy. Our shape changed. The amount of sugar that was visible changed. Okay, so we can say shape changed. Remember when we were talking about, did the sugar cube at the beginning of the 2 minutes take up the exact same amount of space as the sugar cube at the end of the 2 minutes? It did not, because the size got smaller. So we can say size got smaller. And remember, if volume is how much space something takes up. So if the sugar cube at the end took up less space than it did at the beginning, then we can say volume reduced, right? Volume went down. And what properties of the sugar cube stayed the same? Well, not much stayed the same, but we can definitely say that the color stayed the same, right? It was white at the beginning. It was white at the end with the sugar that was left. All right. Now let's go down to number 4, just 2 more questions for today. So number 4 says, record your observations below during the 2 minutes of stirring a whole sugar cube in water. So this time we're going to do the exact same thing. I'm going to add 100 milliliters of water to our cup. We're going to add a sugar cube, and then we are going to stir it. So just let me get my stirring stick. All right, and now we will adjust our camera again right here. So we're going to add 100 milliliters of water. That's about 60 milliliters left. There we go. All right, so we have our 100 milliliters of water. And we are going to drop in the cube. Let's see if we can get this in focus a little bit. There we go. And we can already see it starting to dissolve a little bit. And now I will just stir this water around. All right, so if you look closely, you can see the particles flying off the top of there. You can see the particles spinning through the water. So to me, it looks like the particles from the sugar are coming off much quicker than the particles did when we just had the sugar sitting in the water. Why do y'all think that is? Why do you think more particles are coming off of the cube now than before? Well, what are we doing differently this time than we did the first time? The only thing we're doing differently is stirring it. So if we're stirring it and the particles are coming off faster, what can we say? What effect can we say stirring has on a sugar cube in water? Is it dissolving at the same rate? Or is it dissolving faster? Or is it dissolving slower? Right? So we're about a minute in. Man, this thing is getting tiny. And we're just making observations. Is it still the same color? Is it still the same size? Is it still changing? Has it stopped changing? How's the water changing? Because there's two substances in here. One substance is the cube, another substance is the water. So remember, how's the water changing? Well, we're getting a lot more sugar particles in it. Even though we can't taste it, what do we think the water tastes like now? I lost my light. All right, and that is about the 2 minutes. Let me get some lights back on here. All right, and after 2 minutes, this is the small amount of sugar we're left with. Look, we can see sugar particles floating in the water. We can still see the sugar cube dissolving. Okay, let's go back to our journal. And now, last two questions. So record your observations below during 2 minutes, stirring the whole sugar cube in water. Well, what's something, so right here, y'all write down some things that you observed. Well, one thing we observed, the cube began dissolving faster. What we saw, sugar particles floating in the water. What else did we see? You can add anything you'd like right here. You can definitely add more. There were other things to see. During observations, there really is not a wrong answer. The only wrong answer is not putting anything, because we definitely saw something. And lastly, compare your observations of how the sugar cube dissolved in both of these trials. Was there a difference in how much of the sugar cube dissolved? Why do you think this is true? So let's take our first question. Was there a difference in how much of the sugar cube dissolved? Did the sugar dissolve faster or slower in the second trial? Or did the sugar dissolve at the same speed? Well, the sugar in the second one, while we were stirring, the one we stirred, it dissolved much faster. So was there a difference in how much of the sugar cube dissolved? Yes, there was a difference. Why do you think that is true? So why do you think the sugar dissolved faster the second time when we were stirring? Well, everything was the same. We used the same amount of water. We used the same temperature water. We used the same amount of water. We used the same size sugar cube from the same box. So what was the only thing different? The stirring was the only thing different. So why do you think that it dissolved faster the second time? Because of the stirring, right? So the stirring is what made it go faster. So let's answer our second question. Why do you think this is true? We can say the stirring motion made the cube dissolve faster. All right. Now, I just want to use these blocks. Oh, no. Almost tipped my camera over. All right. I'm just going to use these blocks to explain why it stirred faster, or why it dissolved faster while we were stirring. So let's pretend like, I separate these here. All right, so let's pretend like these pink ones are sugar and these blue ones are water. Well, the first thing we did was we took the water, our water cup, and then we just set the sugar down in the water, and then we didn't touch it. Even though we didn't touch it, the sugar slowly dissolved. That is because even though we don't see these substances moving, their atoms on a molecular level are actually vibrating and moving next to each other. Now, we can't see it because to us it looks still, but the atoms are actually vibrating and wiggling to themselves. So what happens when two things are vibrating or moving and they come in contact? Well, they create friction. So we have the sugar vibrating, and it goes into the water and it's vibrating, and these things are vibrating together and vibrating together. And what happens is we start getting some pieces knocked around, right? So these are just kind of vibrating, and we're going to knock a piece off, and we're going to knock a piece off. And we're not, these aren't hitting each other very hard, but they're just hitting them a little bit here and there. The water molecules are just slowly knocking off these, taking apart all these sugar molecules. And it takes a little while, right? Now, let's put them back together. So that's what it's like when the atoms are just next to each other. Or, when the substances are not moving and are just being still next to each other. Even though they're still, the atoms, even though we can't see it, the atoms are moving a little bit, and they hit and break each other off. So the water just lightly keeps tapping away at these sugar particles and just slowly chips away. Now, when we stir it, something very different happens. Okay? Now, if we know these aren't moving, but in reality they are moving a little bit at an atomic level, what do you think the difference would be if I am up here and stirring these? How much do you think the atoms will be moving? If I'm stirring in a little bit, the atoms are moving a whole lot, right? So here we're not moving it, but the atoms are actually moving. Here we are moving it, so the atoms are really moving. So now what happens, as we're stirring it, these atoms are moving fast, and instead of just rubbing and slowly chipping away, these atoms are crashing into it, hitting it out of here, hitting it out of here, hitting it out of here. Boom, 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 and they're gone. So when we stir it, it creates a lot more motion and a lot more activity in the molecules, And so instead of the molecules just lightly rubbing on each other and slowly shipping off, the molecules are actually knocking them out of there, getting them out of there, busting them out of there. All right, so that is our lesson for today. Tomorrow, we will look at the other, let me get all my sugar molecules out of here. Tomorrow, we will look at our second page, where we will we will carry on from our first page, and over here we'll still dissolve sugar into water with a couple different variables in our experiment. So, we'll see you then, guys. Thanks for your time. Peace.